everyone, my name is Rae Moore and I'm a Quality Research and Training Specialist at Safety Partners. So today I'm going to talk about industrial ventilation, which is a webinar I attended back in January through the New Hampshire General Industry Roundtable. So over here I have a slide that we generally put in our safety training, and this relates to fume hood use. And the whole point of this slide is we are asking everyone to keep the sash as close as far down as possible. And the reason for this is if you increase the area, you decrease what is called the face velocity. And that's the airspeed at a certain inlet. And really you want to be able to protect the worker by, allowing the air to flow through and away. You want to reduce exposure. But there's other types of velocity when you are looking at ventilation. One of them is called capture velocity. It's kind of a similar concept, but it also takes into account the distance from the contamination point to the opening of the ventilation. So, for fume hoods, we remember that the ventilation capture point is sort of a little further down, but there's not always an enclosure between the person and sort of the ventilation capture point. And so we have to keep that into account. Which brings into account ventilation design, and there's definitely some factors that come into play. So in our end, part of the thing we look for as consultants is we kind of look at these and determine whether there's something that needs to be addressed. And so one of these things is the ventilation design. We're looking at, making sure that you look at the capture velocity closest to the person. So you look at where they are working, where's the work surface, where is the potential, where's the contaminant, and where's the ventilation point to make sure that they are, really protected from that potential hazard. And it also depends a lot of other factors, right? It's not just the airflow of the ventilation at the capture velocity, but what other airflows are in its way. So for example, here there's a fan, and if it's blowing air towards the person, even though there's ventilation over here, you're not really protecting that worker from exposure. Other factors are the nature of the contaminant. We mainly think of vapors if you're working with chemicals, right? So there is a certain design velocity you have to take into account. But what if you're protecting the worker from things like heavy dust? That's much heavier, and so you need a much larger velocity in order to really protect the worker. Another factor to consider is resistance to flow. So we normally think of the fume hood, for example, of that ventilation point, right? And we think, okay, well, we protected the worker, that's it. But the contaminant needs to not only get captured, but be transported away so that it is no longer, considered a hazard. And that ductwork really plays a big role. So this is where we're looking at transport velocity, or the minimum velocity required to keep the particles, moving, basically. And so again, the design of the ductwork is really important. We really want it to be round and smooth, no sharp turns, because that's where you sort of kind of hit a wall, basically, and you create turbulence, and it really restricts movement. Also, you want the ductwork to go from smaller to larger, so you don't if it goes the other way around, you kind of hit it like a bottleneck, basically, right? And then it reduces the airflow. The final portion is, well, how does your contaminant leave the building? And that's where discharge comes in. And in order to do that, you need a fan to basically, to draw everything out. And you want that fan not only placed on the roof, but as far downstream as possible. Also, all of this is it's all synchronous, right? Not only the ventilation capture point, but the ductwork and the fan. And sometimes, when in ventilation design, they're like, oh, we'll just have a big fan and we'll just take care of everything. But you have to keep in mind, then there's heating and cooling and air balancing, and you don't want to, that's a lot of big energy waste. So you want to make sure everything's designed appropriately for all facets of, the facility. On top of that, so there are these discharge stacks where the contaminants now leave the building. And they do have to meet state requirements. So every state has different, I would say, air permitting requirements as to sort of things like the height and other factors. And yes, they should point straight up. He did show examples of photos where the discharge stack was sort of, curved, and you could just see the contaminants on at the top of the roof, right? And so, that's not ideal. And you really want, the stack to be high enough so that it can clear the contaminant. And in some cases, there might be a permit required, so looking at state regulations is really important. And other important things to note is to make sure that the discharge stack is located away from the HVAC intake, right? You don't want it coming back in. And also, I think sometimes the design of the discharge stack, they try to put something to protect it from the rain, protect it from coming in. And rain hats are sometimes common, but this particular presenter really discouraged them, mainly because they're sort of like these cone-like hats, basically, that go on. And the problem is it kind of stops the flow of the, contaminants, and then it actually just goes right back onto the stack and really inside too. So he actually recommended they kind of just look like larger tubes that really are meant to protect sort of any lateral rain that comes this way. So rather than rain hats, so it still allows the discharge to go through. Finally, as I already alluded to before, inspection and maintenance is so important to make sure that everything is running smoothly. And it is in different stages. So daily, you just want to make sure that the airflow is appropriate and adequate. You can either do this quantitatively through, there's usually meters or gauges with alarms, and you want to make sure, that the numbers are reading what they should. There's a quick qualitative way, specifically with things like Kim wipes, where you just, take a little Kim wipe, those lab tissues, and make sure it's actually flowing in and the ventilation is actually working as it should. And also you check the system pressure, so all these readings. Monthly, you also do a check of the airflow and direction. And as I mentioned before, any sort of cleaning or maintenance that needs to be done to make sure that there's nothing impeding the capture and transport velocities are really important. And then finally, annually, you want to do like a check and calibration on things like the airflow rates and the system condition, make sure all the parts are working. And this is where you definitely want to have things documented and have those maintenance records ready in the event they're needed for things like an inspection or any permits. All right, thanks so much.